Hello everyone, welcome to Polyset Virtual Training. Today we are going to discuss about circles and similar triangles. What is circle? A circle is a two-dimensional figure formed by a set of points that are at a constant or fixed distance. That is called what? The fixed distance. What you will say it as a fixed distance over here? It is called radius. Okay, so circle is nothing but it is what is it? It is a two-dimensional figure. How it will form? It is a set of point, right? From a fixed that are at the constant or fixed distance from a fixed point. That fixed point, what you will say that as a fixed point as center on the plane, right? So for example, this is my fixed point, right? From here with a fixed distance, I'm just drawing a set of points, right? You can see this. If I'm joining this set of points, what you'll get it from the fixed distance, right? Fixed distance means I have to keep a point exactly at the same equal distance, right? So this is called circle. So this you will say it as what? Center, and this distance from the center, what you will say? This as your radius, right? Fixed point is called center. Fixed distance is called radius. Next we are going to see about parts of the circle. What are the parts of the circle? So let us see one by one. Right? First, as you know, what is a center? It is a fixed point. What is a radius? It is a fixed distance from the center. Right? The outer part, this outer part you can see over here, right? This you will say it as a circumference. What you will say? This is a circumference. Right? Then what is arc? Any part of the circle. So if I'm taking any circumference, right? Circumference you can see over here. Any part of the circle you can say it as what? Arc. Right? So what is a chord? Chord is nothing but it's a line segment. It's a line segment inside the circle. So that line segment, what is meant by the line segment name is called chord. Okay. A region enclosed by the line segment is called what? It's called segment. A line segment, what you will say, that is a chord. A region enclosed by the chord is called segment, right? Then when two radii are joined, what is that? When two radii are joined, a region you will get it, right? That region is called sector. What is this region is called? Sector. When two radii joined, you will get a region as sector, right? The longest chord in the circle, you will say it as a diameter, right? Then a line passes through the circle. A line passes through the circle. Line segment, what you will say? It is a chord, right? A line passes through the circle, you will say it as what? Secant. It is called secant. You can see two touching point it will have, right? Same way, if a line touches only one point, one external point, then that is called what? Tangent of the circle. Okay, one external point you can see exactly on the circumference, you can see it is touching, right? So this line you will say it as what? Tangent. So here what is the relationship between the diameter and the radius? Diameter is nothing but twice of radius. Okay, twice of radius, you will say that as a diameter. Now we are going to discuss some important formulas related to this circle. Okay, area related to the circle. So what is the area of circumference of a circle? It's nothing but 2 pi r. Then what is the area of a circle? Pi r squared. Right, now we learnt about what is sector and what is segment, right? And we are going to discuss about now semicircle also. So what is a sector? When two radii are formed, joined, that this region, what you will say? This region and this region, what you will say? It is a sector. So the small here you can say this as a minor sector and this is as a major sector. So what is the length of an arc AB? So this length they are asking. Okay, this length they are asking you. So what is the length of an arc AB? So theta by 360 into 2 pi r. So what is a perimeter of a sector? What is a perimeter of a sector? It's nothing but 2r plus length of an arc. What is a perimeter of a sector? OAB. It's nothing but completely this perimeter, overall perimeter, what you will say that as 2r plus length of an arc. As you know, what is the length of an arc? Theta by 360 into 2 pi r, right? So what is the area of a sector? It's theta by 360 into pi r square. Right, next we are going to see about the segment. What is a segment? A region enclosed by the chord. Chord is nothing but a line segment drawn inside the circle, right? So region enclosed by the chord, what you will say that as a segment. This is as a minor segment and this is as a major segment. If they are asking you to find the length of a chord, so what is the length of the chord? Here, what is the length of the chord? You will get it. It's 2r sine theta by 2. What is it? 2r sine theta by 2. Right, what is the area of a segment? When you want to find the area of a segment, what you will do? You have to find out this area of a sector minus area of a triangle. Okay, so what is the area of a sector? Theta by 360 into pi r squared minus, what is the area of a triangle? Half r squared sine theta. That you can remember it, right? Then what is a semicircle? Half of the circle, what you will say? That is called semicircle, right? So perimeter is nothing but what? Pi r plus 2r. Same way, what is area? Half pi r squared. Half pi r squared. Now this is a shape of ring, right? Ring means you will have two radius. One is inner radius, another one is outer circle radius. So what is the perimeter for that? 2 pi r plus r. Then area is nothing but pi r squared minus r squared, right? Capital R tends to the outer circle radius and small r is the inner circle radius. So these are the main formulas what you have to remember. Okay, next we are going to see one problem. Find the area of a segment AYB. They are asking what? This segment they are asking you, right? This segment, as you know, what is this part they are asking? AYB, right? This segment AYB. If the radius of a circle is 21 centimeter and the angle AOB, this angle they have given as how much? 120. Okay, then use pi as 22 by 7. They have given very clearly, you have to use pi as what? 22 by 7. So what is the radius? As you know, 21 centimeter AO. So what is the area of a segment we learnt? Area of a sector minus area of a triangle. So let us see what is area of a sector. Area of a sector is nothing but theta by 360 into pi r square, right? So what is theta here? 120 by 360 into 22 by 7 into 21 into 21. So what you will get it now? Here 7 ones are 7 threes are, right? Same way here 3 ones are, here 3 ones are 3 to 120. So what you will get it now? This and this will get cancelled 1, right? So 22 into 21 will give you 462 centimeter square. Now we have to find the area of a triangle also. What is the area of a triangle we learnt? Half r squared sine theta. Right, what is r square here? R is 21. So 21 into 21, 21 into 21 into sine 120. So as you know, sine 120 is nothing but, I can write sine 120 as what? Sine 90 plus 30. It's nothing but cos 30. Cos 30 is root 3 by 2. Okay, so after multiplying all this, what you will get it? 270.05 centimeter square. Okay, now what I have to do? I have to subtract from this to this, right? To find the area of a segment. So 462 minus 270.05. It's nothing but area of a segment is what? 191.95 centimeter square. So this is the area of a segment, right? So next we are going to see some important theorems which will helpful to you to solve your problems. Okay, so first theorem. What is the first theorem? Tangent perpendicular to the radius at a point of contact. Always. See, this is a tangent. As you know, a line passes externally, right? Only one touching point. So this is this point. Always it is what? Perpendicular to radius. You have to remember what it is? Perpendicular to radius. Always it will be 90 degree. Okay, always it will be 90 degree. You have to remember this. Next, a length of a tangent drawn from the external point. When the length of the tangent, two tangent you can draw, right? So this, always you have to remember that this two length are equal. What is this? Two length of the tangent are always equal. Here you can say that was what? PQ equal to PR. Always the length of the tangents are equal. What is the first point we learnt? Always the tangent is perpendicular. If I'm taking this, right, this is a touching point. Okay, so this is 90 degree. Same way, this is a touching point to the radius. So this will be 90 degree. Always, what you can say over here, a tangent is the length of the tangents, always it will be equal. Next, we are going to see about some important. If two concentric circles, the chord of a larger circle which touches a smaller circle is bisect at the point. Right? The tangents drawn at the end of the diameter of a circle are parallel. Okay, whatever the tangent you have drawn, okay, at the end of the diameter of a circle, then that is called what? Parallel. That are parallel. A perpendicular at the point of contact of tangent passes through the center. Circle to contact to the tangent to a circle passes through the center. Next, the angle between the two tangents drawn external from the point is supplementary. So this is very, very important. The angle between the two tangent drawn from the external point to a circle is supplementary to the angle subtended by the line segment joining at the points of the contact at the center. Okay, so then a parallelogram circumscribing a circle is a rhombus. Right? If a parallelogram circumscribed by a circle is called what? Rhombus. The opposite sides of the quadrilateral circumscribing the circle subtend supplementary angles at the center of the circle. So what it will make? It will make supplementary angle at the center of the circle. Right? So as we have seen, what is that meaning of that two tangents? Angle between the two tangents drawn from an external point of a circle is supplementary to the angle subtended by the line segment joining at the point of the contact of the center. So what they are trying to say over here, it is nothing but APB. This angle, right? This angle and BOA, this angle. Always this angle add ups and give you how much? 180. What you have to remember, this angle and this angle always add up and give you 180 or supplementary. If I add this two angle, I'll get it 180 degree. Sometimes they might give you the angle over here 75 degree. Okay, and they can ask you the what is the angle over here at the center. So what you will do? It's nothing but 180 minus 75. So what is the answer? You will get it over here 180 minus 75. It's 5, right? It will be 0, then it will be 7. 17, right? 180 minus 75, it's nothing but 105. Okay, it's 105 degree. Okay, so this is a very important theorem as per your exam point of view. Then next, we are going to see one problem, how to solve this. Okay, so what they are asking over here is you have to find angle AOB. This angle you have to find it out. Okay, AOB. As you know, what is this? The touching point of a tangent is how much it will be? 90 degree, right? So here it is 50 degree, means how much it will be? Obviously it should be what? 40 degree. Right? Obviously it must be how much? It is 40 degree. Same way, what about this also? Here also it will be 40. Since OA and OB are the radius, right? If it is 50 degree here, obviously it will be also what? How much here it will be? 50 degree. So obviously here it will be how much? It will be 40 degree. As you know, this is 40 and 40. So what is the sum of angle in a triangle? See, you can see over here. First, what they have given, angle PAB is 50 degree. This is angle they have given. But as we know, it is angle between the radius and the tangent PA. Right, it should be 90 degree. So PAB plus OAB gives you how much? It is 90 degree. So it is nothing but OAB is nothing but how much? It will be 40 degree. As you know, PA equal to PB. PA equal to PB. Right? If this two lengths are equal, obviously what you can say? PBA equal to PAB. Right? Then what you will get? PBA is also nothing but 50 degree. Since this lengths are equal, the angles will also be equal, right? Now what you will get it? PBA plus OBA. Same, it is how much? 90 degree. As we know, 50 plus OBA gives you 90 degree, right? So OBA, this angle will also be how much? It will be 40 degree. Now, so in a triangle, what we are having? Angle AOB. Angle AOB plus angle ABO plus angle BAO. This three angles gives you what? 180 degree, because sum of angles in a triangle. Right? So it is nothing but AOB plus 40 gives you 180. AOB is 180 minus 80 gives you how much it is? 100. Okay, so here we have used two properties. What are that? One is, and the tangent touching point from the radius gives you always what? 90 degree. The tangents will have equal length. Okay, then next up, what we are going to do over here, we have to find out TRQ. What we have to find out? TRQ. This angle we have to find it out. This angle we have to find it out, right? So we know that what we know over here, we know that tangent is perpendicular to the radius. So this too is a tangent. Okay, perpendicular to the radius. Hence what you will get it? OTQ, right? OTP and OQT. So this angle will be how much? It will be 90 degree, right? Obviously this will be 90 degree. Okay, so what I'm doing in the quadrilateral, so this is a quadrilateral, right? Four sides. So P, what is a quadrilateral we are taking? P, Q, O, T. This is a quadrilateral I'm taking out. Okay, so in that, if I'm taking out, if I'm adding up all the angles, how much it should give? 360, right? Four angles if I added, it will be 360. But as we know, TOQ, see here, TOQ plus TPQ gives you how much? 180 degree. Okay, so TOQ is how much? It is 110 degree. Okay, it is 110 degree. So here, see, because since it is a tangent, as we know, what is the supplementary angle? TOQ, you will get it here. TOQ, TOQ, this angle at the center, it will be how much you will get it? It is 110, because just now we have seen, right? This is a supplementary. This makes for how much? Supplementary. So if it is 70 over here, angle at the center, it will be 110 degree, right? So here we are having one more theorem. Angle subtended by the arc at the center of the circle is twice by the angle subtended by it in an alternate segment. So if it is 110, this will be half of this, because this is angle subtended at the center of the circle, right? So this is in the alternate segment. So what you will get it? Here if it is 110, you will get half of this, right here. So it is nothing but 110 equal to twice of TRQ. TRQ is equal to 55 degree. These are the major things you have to understand in the circles. Now we are going to see about similar triangles. Okay, before going to the similar triangles, let us know what is triangle and what type of triangles we are having. Then we'll go for the similar triangle. First of all, let us know what is triangle. Triangle is nothing but what? It is a closed figure formed by joining three line segments. Okay, joining three line segment. It is a closed figure formed by joining three line segments. You will get it as a triangle. Right. So what are the types of triangles? So in the types of triangles, we are having based on sides, based on angle. Okay, based on sides, if three sides are equal, you will say that as a equilateral triangle. Here you have to remember always all the angles in the equilateral triangle will be equal to 60 degree. You will have three angles, right, in a triangle. So it will be 60 degree. So then if two sides are equal, then you will say it as what? Isosceles triangle. Okay, in that two angles will be equal, means as you will say base angles will be always equal in the isosceles triangle. Okay, here you can see this is your base, right? So base angle will be always equal in isosceles triangle. So no scalene triangle means no angles, no sides, nothing will be equal in that. Now if I'm classifying the triangle based upon the angle, first one, if I'm having any one angle as 90 degree in a triangle, then it is a right triangle. Okay, if all angles are less than 90 degree, if all angles are less than 90 degree, then what you will say? It is a acute angled triangle. Okay, if one angle, out of this one angle, out of three angle, one angle is greater than 90 degree, then you will say that that triangle is what? Obtuse angle triangle. Okay, next we are going to see about what is similar triangle. What is similar triangle? Two triangles that have a same shape but a different size. Okay, for example, if I'm saying that, see, you people are looking similar, it means what? By seeing you might be similar, right? But what about your height, weight and all? It will be different, right? We can't say it is same, right? That is called similar triangle. So in that, when you will say the two triangles are similar, by seeing the shape might be same, but it will have what? Different sizes. As you know, like a shirt example, you can take it, or any dresses. If you are wearing the similar dress, you and your friends are wearing a similar dress, but the size won't be same, right? So that is an example. So if it is a case, the corresponding angle measures are congruent. Corresponding sides are what? Proportional. Corresponding sides will be what? It will be proportional. Okay, so this is a symbol for the similar. Like this you will draw. Okay, this is a symbol for a similar. So how will you read this now? Triangle ABC is similar to triangle DEF. If it is a case, this angle is equal to this angle. Okay, this is equal to this. And same way angle B equal to angle B. But this is AC by DF equal to CB by EF equal to AB by DE. So this will be in proportional, right? So what is the meaning of proportional over here is AC by DF equal to same way CB BC by EF, okay, equal to AB by D, okay, AB by D. So always it will be proportional. Proportional means their ratios will be equal. Always the ratios will be, it will have a constant ratio. Okay, this is the thing you have to understand. Next, we are going to say how you will say that as a similar triangle. Okay, so always the corresponding angles are equal, right? Just now we have seen what is the corresponding sides are in the same ratio. You can say this as in the same ratio. Okay, so to test this, we are having in similar triangles, we are having a different criteria to test this. Okay, let us check what are the criterias we are having it. So if you can say over here, you can see over here, right? So A by B. So what is that? See, this side and this side is proportionate, right? This side is equal to this side. So here you can see, right? So this is equal to AP by BP equal to B by Q equal to C by R, right? So this is a thing. So let us see what are the criterias you will say whether it is a similar triangle or not. To understand this, based upon first side. What is based upon? SSS, right? 3 sides are respectively equal. Then next we will say that side angle side. What is that? Side, one side will be equal. Then what is 2 sides? You can see over here, inclined angle, right? 2 sides and the inclined angle are respectively equal. Okay, then ASA, angle side angle. What is it? Angle, one angle will be equal. Same way another angle will also be equal. That side will also be equal. 2 angles and the included sides are respectively equal. What is that? ASA. Okay, then you will have RHS. You will have what? RHS, right angle hypotenuse side. One more you will have it as AA, angle. Okay, you will have as angle. Another one also is there, that is angle and angle. AA criteria also will take it. Right angle triangle, it is hypotenuse and one sides are respectively equal. So based upon this criteria, you will say it as what? It is this 2 triangle are similar or congruent. Based upon what? Side angle side, or as angle side angle, or AA criteria, or RHS criteria, right angle hypotenuse criteria. Okay, next we are going to discuss about triangle proportionality theorem. What is a proportionality theorem? When a line is drawn parallel to the base of a triangle. What is it? When a line is drawn parallel to the base of a triangle, then it divides the sides into a proportional to the corresponding segment. What? It divides the sides into the proportional corresponding. So what are the sides we are getting at? BD by DA. What is that? BD by DA equal to BE by EC. Right? Either you can write like this or you can write a DA by BD equal to EC by. So this is a proportionality theorem. When you are getting a line parallel to the base, obviously it will divide the sides into its proportional, right? Based upon this, how will you find out? Let us understand through this problem, right? So this is a line parallel. They have given DE is parallel to AC. Okay, then they have given this X, right? So you have to find out the missing side now. So how will you find it out now? As we know, BD by DA equal to BE by EC. So what I'm doing over here now? So 4 by 8 equal to X by 9. Okay, so 4 by 8 is how much? It's nothing but you can write it either 1 by 2 or you can do the cross multiplication to remove the denominator. So 36 is equal to 8x. So x is nothing but 36 by 8. It gives you 4.5. So you can use the basic proportionality theorem and PPT theorem to find out the missing measurement. Okay, next we are going to see about areas of a similar figure. What is mean by areas of a similar figure? As you know, there is a relationship between the area and its sides. Okay, if they are saying the two triangles are similar, then the area will be, the ratio of their areas will be square of the ratio of their sides. Okay, what is it? The ratio of their areas will be square of the sides. Square of this ratio of their sides. Okay, so let us understand this through the problem. See, find the area of a triangle. What they have given over here? They have given area. One of the triangle area is 45 centimeter squared, and one side what they have given 3 centimeter. Same way in the another triangle XYZ, they have given side as what? 5 centimeter, and the area they are asking you. Right. So what we learned it already previously, the ratio of their areas of two similar triangles will be the square of their ratios, right? Square of the sides of their ratios. It will be there. Say ratio of their sides, right? So what you will get it over here? It is, what is this sides actually? What is area? You can take it as A1, area 1 by area 2. It's nothing but square, right? So you can take it S1 by S2 squared. Okay, like this you can take it, or you can write it separately. It's your wish. Okay, then what is the area 1 I have taken? So I can take it this as a first triangle area by this triangle area, right? For this triangle, what is the side I'm getting it? It's nothing but 9, right? 3 squared is 9. Same way 5 squared is 25. So what is the answer? You will get it over here. 25x is equal to 25x is equal to, we'll get it, 25x is equal to 9 into 45. Okay, if I'm simplifying this, what you will get it? 9 into 45. So x is nothing but 125. Okay, so you have to remember this thing. What is the important thing you have to remember is nothing but ratio of their areas will be equal to the square of the ratio of their sides. Okay. Next we are going to discuss about Pythagoras theorem. What is Pythagoras theorem? This theorem is specially meant for right angle triangle. Okay, when the triangle is a right angle triangle, then it shows the relationship between the sides. Okay, so here you can see always wherever the right triangle is there, opposite that side is called hypotenuse. That is called what? Hypotenuse. This you will say it as A and B are the two shorter sides. Always that will be adjacent to the right angle. Okay, so always you will say the hypotenuse as what? Longest side. So what is the relationship between these three sides? So it's nothing but a squared plus b squared equal to c squared. It's nothing but hypotenuse square is equal to sum of the squares of other two sides. Okay, so this is a relationship. This is called Pythagoras theorem. Now let us try to solve this through the problem. So what they have given over here, so it is a right angle triangle. Obviously, you know, it is 8 centimeter on of the side. Hypotenuse is what? 17 they have given. They are asking you by seeing a right triangle, you know what is the relationship between that, right? So what is the relationship between that? It's a squared plus b squared equal to c squared. It's nothing but hypotenuse squared equal to sum of the squares of other two sides. So what is that? 8 squared plus u squared equal to 17 squared. What is 8 squared? It is 64 plus u squared equal to 289. So u squared equal to 289 minus 64. It's nothing but 225, right? So what is u? Square root of 225. It's nothing but u squared is equal to square root of 15 square. So u is 15, right? So what is the missing side? You got it as 15. I hope so. Now circles and similar triangles are very clear to you. Thank you for watching.